Assalamu alaikum. Today in this video lecture I come up with more numerical problems which of course are from the practice questions, and I thought you might get some problems, so it's better to discuss it over here. So the question is like this: a three-phase cable is supplying 800 kilowatt and 600 kVAr to an inductive load, definitely an RL load. It is now intended to supply an additional resistive load of 100 kilowatt through the same cable, okay, without increasing the heat dissipation of the cable. By providing a three-phase bank of capacitor connected in star across the load, given that voltage is 3.3 kV 50 Hz, we need to find out the capacitance per phase that is required to put in at the load side, which is connected in star. First, the load is like this. This is a per phase circuit of the same system. Here it is a source voltage, this is the cable through which the power is transmitted, and this is the load. And load is again, this is 800 kilowatt plus 600 kVAr. Now this is equivalent circuit where RC represents the resistance of the cable, XC represents the inductance of the cable. I am neglecting the capacitance of the cable for the time being, and RL and XL are the resistance and inductance of the load respectively. In this case it is given that I can write or represent the load in terms of complex power, that is SL1, that is before modification it is 800 plus J 600 kV. I have written in terms of complex power. So what is now intended, we have to increase additional power. That means we are actually uh, connecting a resistor over here, and this resistor should be in such a way so that it should draw 100 kilowatt of the power. Let us say I represent it by R2, RL2, this is RL1. Now the condition is that this power should be drawn by RL2, but the heat dissipation, that in this RC, should remain the same in both the cases. That means before connecting this RL2 across this, the current was I, and when I connect this RL2 across the load, the current should remain, sorry, the heat dissipation should remain the same. So let us first see how this happens. What is the parameter that should remain the constant? The PL1 is the heat dissipation in the cable, that is this I square RC, I square RC. So it should be PL2. It is again, let us say it may be written, it should be equal to, this is I1, this is I2 square RC. When we equate both them from this, it comes out to be I1 should be equal to I2. Let us call it as I. That's why I have written over here I. But in this circuit, it is not possible. You can see that this I should be equal to this current plus this current. Before connecting this, I assume this to be I, and after connecting this, I am saying that this is again I. But this is only possible when I use a capacitor over here, this C. So I have to calculate this C so that before connecting this R and after connecting this R and C parallel to this circuit, the current should remain the same, because you know that this will be definitely a lagging current, because this is here inductive circuit. Capacitance will draw the leading current, they will cancel each other, so that the total current should remain the same. So we concluded that in both the cases I should be same. Now since we are assuming that at receiving end voltage should remain same and it is equal to 3.3 kV, that means when I multiply this V into I, it is apparent power, that means apparent power should remain the same. This actually I did to solve it by using the power triangle. So in first case, what is the value of apparent power, we can calculate in this triangle. Actually these two triangle I have superimposed over here. First I will explain this triangle. This is the 800 kilowatt, that is P, and this is 600 kVAr, that is Q. It is actually given in the question that the load is inductive, 800 kilowatt is it is supplying 800 kilowatt and 600 kVAr. So power triangle can be represented by this triangle for the first case, and by simply squaring and adding these two, because this is a right angle triangle, it will be 1000. 800 square plus 600 square, square root of the whole, it will give us 1000. Now in the second case, we have to keep this apparent power same, that this 1000 should be same, but this has to increase. This has to increase. While doing so, when this increases, this remains the same. It means this QL2 has to decrease. This QL2 has to decrease as compared to QL1. You can see it from here. This is the first triangle like this. This is 800, this is 600, and this comes out to be 1000. Now I will draw an arc with center this, whose radius is equal to 1000, and draw it like this. So from here to here, sorry, it is plus 100. That means 900. From here to here it is 900. So I can draw this apparent power like this. It will be again 1000. So what I mean to say is that now you can see that this QL2 has to be less as compared to this. In other words, we can see the capacitor has supplied some reactive power to this inductor, so that the reactive power sent from the source and will be now less. That is actually this QL2. Now in this case, we can calculate now QL2. That's very simple now. This QL2 will be equal to this, in this triangle, 1000 square minus 900 square, square root, it comes out to be 435.89 kVAr. But QL1 is equal to 600 kVAr. That means this QC, that is the actual reactive power that is supplied by the capacitor, will be this much. That will be the difference of the two. That will be equal to 600 minus 435.89. That comes out to be 164.11 kVAr. Now from this we can calculate this per phase capacitance. You can see this QC will be equal to, since it is a three-phase system, it will be 3 times Vp is the phase voltage, because it is connected in star. A phase voltage will appear across the capacitor. Vp square divided by Xc. 3 Vp square into omega c, because Xc is equal to 1 by omega c. From here, this c, this whole term will be divided to this, will be equal to Qc divided by this 3 into Vp square into omega. So it comes out to be 164.11 into 10 raised to power 3 divided by 3 into 3.3 into 10 raised to power 3 divided by root 3. It's a phase voltage का whole square into 100 pi. It comes out to be 47.96 microfarad per phase. I hope you understood this. There is one question in which there is a correction in the question. I was just checking the questions last time. So it is in the insulators practice questions, question number 6. In the question I have written there, the capacitance from each unit is 12.5% of the capacitance of each unit. Actually, I have missed these two words, to earth. Actually, this should have been like this. The capacitance from each unit to earth is 12.5% of the capacitance of each unit. Please, if you haven't done yet that question, please correct that question. Just put these two words here and try to solve it. Now the next question is from sag and tension, question number 7. So in this case, the two supports are supposed to be at equal height, and the span between the two supports is given to be 275 meters. It is given, the data is given like this. Diameter of the conductor is 19.5 mm. Weight of the conductor is 0.85 kg per meter. Span is 275 meter, and safety of factor is 2. And ultimate strength is given as 8000 kg. In this case, if you see, there is no safety factor given, so you can assume it to be 2 if it is not given in the question. In this case, what we are asked to find out, calculate the length of the conductor between the point which is 30 meter from the lowest point of the conductor and the supporting tower. So we need to calculate the length of the conductor from point which is 30 meters from the lowest point. This is the lowest point O, and the point on the conductor 30 meters from this point will be, let's say, point C, and we need to calculate from the least point and the supporting tower, that is this. That means we have to calculate this Z or AC. We need to calculate the length of this catenary that is this Z or AC. So how to do this? We know that this is actually a catenary, and its equation is given by S is equal to x plus w square x cube divided by t square into 3 factorial. It is actually the length of the conductor or catenary between the point O from this to any point x from O. That is this. From this to any point x, it is given by this equation, where x can vary from 0 to L by 2. L by 2 is the length of the span, half span of the conductor. So we can say that x is an arbitrary point between from point O uh, to A. Now T is equal to, that is the tension. The required tension will be equal to 8000 by 2, because 2 is the safety factor. It comes out to be 4000 kg. Now length of OA, that is at x is equal to L by 2, because we can calculate first the whole length, then we can calculate the length OC, then subtract them. Then we get the, because this gives us the equation that we have written over here. This gives the distance from this point to any other point, but in the question it is asked we have to calculate AC, that is distance from A to C. So we need to first calculate the distance of OA and then OC, then subtract them. So that's why in this case I write it as L by 2. So SOA, that is when x is equal to L by 2, so I have replaced this x by L by 2 here. It will be equal to W square. This L by 2 will be equal to W, when it's x cube, L cube by 8. This T square 3 factor will be 6. So it comes out to be L by 2 plus W square L cubed 48 T square. This is the, we can say, length of the half length of the conductor. The full length of the conductor will be multiplied by 2. You will see L by 2 multiplied by 2 will be L. This 48 when multiplied by 2, 1 by 48 multiplied by 2 will be equal to 1 by 24. Rest will be same. This is the actual length of the conductor. So this has actually derived from this equation, but I have given this extra information. We need to calculate this half length. So when I put the values, different values, it comes out to be this 275 by 2 plus 0.8 square, 85 square, into 275 cube divided by 48 into 4000 square, that is 137.52 meters. This is the length of OE. Now we can calculate length of OC at x is equal to 30 meter. That means length of OC, that is at x is equal to 30 meter. SOC will be equal to 30 plus 0.85 square into, this will be 30 cube divided by 4000 square into 6. It comes out to be this value. Just a minute, I will check whether it is correct or not. 30 plus 0.85 square into 30 cube divided by 4000 square divided by 6. Yes, it is correct. So this Z or AC will be equal to OA minus OC, that is equal to 137.52 minus 330.0002. That comes out to be this value, 107.5198. This actually, if you see, there are total 2 equations which can be used generally in case of sag and tension. One is this: S is equal to x plus W square x cube by 6 T square, by 6 is the 3 factorial. This is used to calculate the length of the conductor at different points. So length of the conductor, total length of the conductor will be equal to L plus W square L cube divided by 24 T square. This we have put as x is equal to L by 2, and then multiply by 2, we get the total length. So you should remember this formula just to calculate any length in any type of problems. And the vertical distance y, it is given as W x square divided by 2 factorial into t. That comes out with W x square by 2t. This is in general. When x is equal to L by 2, we get the maximum vertical distance, that is the sag. In that case, when x is equal to L by 2, we get W L square by 80. That is also known as sag. So you generally should remember this formula. then you can calculate any vertical distance. This vertical distance is the maximum sag WL square by 80. But in general, if you have to calculate any other vertical distance, you have to, what I mean to say is that in general you have to just remember these two formulas for calculating length of the conductor or sag. And the last one is this question. This very simple question. It is actually a modification of it is not from any objectives or any practice questions. I have deliberately chosen it from somewhere to discuss it with you, because sometimes you may be asked to modify the ABCD parameters of transmission line, and how can you modify it. This is very simple, but just you should understand what are the different steps to do that modification. The question is, the ABCD parameters of a three-phase overhead transmission lines are: A is equal to D, 0.9 angle of 0, B is equal to 200 angle of 90, that is 200 J, and C is equal to 0.95 into 10 to the power minus 3 angle of 90 S. Is the shunt admittance, neglecting the conductance. At no load condition, a shunt inductor is connected at the receiving end of the line to limit the receiving end voltage to be equal to the sending end voltage. Find the ohmic value of the reactor. So normally what is done, we have this system, the transmission network. This is receiving end current, receiving end voltage, sending end current, sending end voltage, and it is described by the ABCD parameters, whose equation is written like this: Vs is equal to AVR plus BIR, Is is equal to CUR plus DIR. Now we know that because of the Ferranti effect, when IR is equal to 0, this VR will be equal to Vs by A. VR will be equal to Vs by A, and A is equal to 0.9. A is equal to 0.9. It means this VR will be greater than Vs. Just to limit that, because we know that this Ferranti effect is the capacitance effect of the transmission line. To limit that, we need to consume that reactive power which is generated by the capacitors, and to consume that we need a reactor at the receiving end. That is why we connect a reactor at the receiving end like this. Now the receiving end current will not be IR, it will be IR dash. It will be modified. When this will be IR dash, some current will be drawn by this reactor, and because of that current, it will consume the reactive power and try to reduce the voltage. Depending upon the value of this Z, the voltage will be reduced. Now we have to calculate that value of the Z when this VR is equal to Vs. That means nominal value. Now for this case we need to find out the ABCD parameter of this system in terms of VR and IR dash, not IR, because now it will be modified, because receiving end will now receive IR dash, not IR. So this IR will be now from here, it will be equal to, I can write KCL at this point. This will be equal to, IR will be equal to this current plus this current. This current is IR dash, I have written it as it is, and this current will be equal to VR divided by Z. VR will not change, it will remain as it is. So I will replace this equation, that is this equation. I will replace IR by these two terms. So I write this Vs is equal to AVR plus B multiplied by this VR by Z plus IR dash. So VR has two terms now, B by Z and A. So I will take this common, and it will comes out to be A plus B by Z is into VR plus B into IR dash. Similarly Is, since I don't require it, but I will write it for you, it will be C plus D by Z VR plus D into IR dash. Now from first, you can see at no load IR dash is equal to 0, like we did it from here. For this case, this equation reduced to this value, Vs is equal to A plus B by Z into VR, this is Z, plus 0. That means when Vs is equal to VR, that means this term should be equal to 1. This term should be equal to 1. That's why I have written it like this. So I have taken A to this side, it will be 1 minus A is equal to B by Z, or Z to this to here, Z is equal to B divided by 1 minus A. B is given as 200 angle of 90 degrees, 1 is 1, and A is given as at angle of 0. So it is not required to write it up, but I am writing it for you. So this comes out to be 200 angle of 90 divided by 0.1, that is 200 angle of 90, that is 200 G, an inductor of ohmic value 200. So we can say that ohmic value of that inductor will be 200 ohms. So this is quite simple. I hope you understood this. I am posing a last question to you. It is a similar question, but it is based on Z parameters. We know that Z parameters, this is V1, this is V2. It is given as Z11, Z12, Z21, Z22 multiplied by I1, I2, and system is same. Let us say it's a transmission system. This is IS, sorry, IR. This is VR, and this is, I can write it as, sorry, I will write it as I2, V2, I1, V1. So here V1 is equal to VS, V2 is equal to VR, and I1 is equal to IS, I2 is equal to IR. Actually, I pose it because I write it like this. I should write it in terms of VS, VR. So I hope you understood this. Now, what I mean to say is that I have to modify this. What I did, I add a resistance in the source side and this transmission network as it is. The rest is same. Let us say its value is 1 ohm. Its value is 1 ohm. You have to find out this Z matrix. Z11 dash, Z12 dash, Z21 dash, Z22 dash. This is I1, this is I2, this is, let's say, V1 dash. I will write it as I1 dash, I2 dash, V1 dash, and V2 dash. This is V2 dash, I2 dash. You will see that there will be no change in V2 dash and I2 dash. This is I1 dash and V1 dash. Again, I1 dash will be same, but V1 dash will change. You have to represent this Z11, Z12, Z11 dash, Z12 dash, Z22 dash, Z21 dash, and Z2 dash in terms of this Z11 and this 1 ohm. You have to see how modification is. If you give me this answer, then I will understand that you have understood this question. Thank you very much.